M6C1 test capacitors. Question number 14, which follows on from question 13. Now we need to calculate the charge stored on the capacitor after a time of 20 seconds. So 20 seconds is within the time limit from when the switch flicks from position 1 to position 2, so we're still going to be using the left hand side of this circuit in this charging diagram. So filling in all the numbers from the question 13, adding that the switch is currently in the position number 1, and we're looking at a charging situation, the charge being placed onto the capacitor. So we'll be using this equation over here, Q equals Q naught, brackets 1 minus e to the minus t over RC, close brackets. This is our charging up a capacitor equation for charge. We're going to need to work out a value to use for Q0, which would be the maximum amount of charge that could be stored on this capacitor using this potential difference. So we would use the defining equation for capacitance, which is the amount of charge stored per unit potential. Rearrange that to make charge the subject, which is going to be to make charge the subject, which is just going to be the capacitance times the voltage times the potential difference, the EMF of the cell here. And that is going to form our Q naught, which will then be placed into this equation here. Once we've got that value for Q naught, we can work out what the charge on the capacitor is going to be at any time, particularly 20 seconds, charging through a resistor of 40 kiloohms, and of course the capacitance is 580 microfarads.